Hi, so we continue with section 1.2 and this is the last video. In this one we have to deal with the theorem 1. So I apologize, there was a mistake in writing the statement of the theorem 1. I have corrected it and posted the correct notes. So instead of checking the continuity of f and f partial f by partial x, which we were doing, we have to actually check the continuity of partial f by partial y, not partial f by partial x. So we have to check the continuity of f and partial f by partial y. So let's see if you understand. So the first problem, we start by first putting it to the proper form, the equation, which should be like dy by dt is equal to ty plus sine square t. So we can see that our f of t is f of t y in this case is t times y plus sine square t. So we can see that f is continuous on negative infinity to infinity because there is no function which will be discontinuous anywhere. Now we have to check the continuity of partial f by partial y, which in this case will be just the value t, just the variable t, because this is what will give us t, and the second term here does not have a y in there, so it's like a constant term, so we have the derivative will be 0. Now this is continuous on negative infinity to infinity, and the given point which is pi 5, that is going to belong, basically we are checking for the pi, so pi is in these intervals, so we are fine. So we say yes, theorem 1 implies the IVP. So which IVP? The one we are looking at in this problem has a unique solution. So this is how we will answer. Looking at this next one, now the function is already in the proper form. So our f, x, y. So here the independent variable is x, dependent is y. So the function f of x, y is 3x minus cube root of y minus 1. So remember, we have to check the continuity of f and partial f by partial y. Since we need partial f by partial y, so I'm just going to first find that. So that will be, so first term you can see there is no y, so the derivative is 0. Second will give us negative 1 over 3 times y minus 1 raised to 1 over 3 minus 1, so negative 2/3, which can be written as 1 over 3 times y minus 1 raised to the 2/3. Now if you want, you can put it in the radical form, but if you leave it like this, it's fine. But now notice that this is fine. This is continuous on negative infinity to infinity. But the bottom one, you can see that there is an interruption. So this one, not continuous at y is equal to 1. And our point, note here, the given point is 2, 1. So we are given the condition is that y of 2 is equal to 1, but y cannot equal 1. So therefore theorem 1 does not apply. So we cannot apply theorem 1. So that's all. That's what you have to do. So check the continuity of f and partial f by partial y. So this is the end of section 1.2.